All right, y'all, welcome to this video where the objective will be students will be able to solve real-world problems by creating linear equations, which is standard there as well. So we have real-world situations which we can model by creating an equation. And so that equation can let us use that to make predictions about the future or, use the equation to figure out more information. So we have a situation here. Mr. Golden's hair is already 10 inches long. It grows at a rate of 4 inches per month. Create an equation that represents the relationship between the length of his hair, L, and the amount of months passed. Because it's growing at the same amount each month, I know that that is a linear function because linear functions grow at a constant rate. And with a linear function, I can use the equation y equals mx plus b. I also kind of want to note that the order doesn't matter. You could also do y equals b plus mx. These are the same equation. And so every linear equation has two parts. Where do we start and how much are we changing by? And here my hair starts at 10 inches long. That's the constant. So this will go in for b. You don't need to make both equations, but I am going to. So b is positive 10, right? That's where we begin. That's our y-intercept. It's positive 10. My hair is growing 4 inches per month, and that's the rate of change. And so the rate of change goes into m. And it's 4 inches per month. So I'm going to use the variable it told me to use for month, which is m, and my plus sign there. And so all of this is equal to the length of my hair. And so now I can plug in an L that represents the length of my hair. And so either of these equations are correct. You could, again, you only need to have one, but on a multiple choice answer, you need to be able to recognize they're both true. What do these equations say? Well, my hair begins at 10 inches. It grows 4 inches per month. This is just an equation story, and that is equal to the length of my hair, right? So the second question asks us to use that model to figure something out about the real world. It says, how long will his hair be after 4 months? I don't have a ton of space here, so I'm going to try to write small. Well, variables represent unknown. So this m right here is representing an unknown amount of months. But now I do know the amount of months. It's 4. And so I don't need a variable to represent this. I can replace it. So I can rewrite this equation as L equals 4. And then I'm also going to plug in a 4 here. 4 times 4 plus 10. And now I can solve. 4 times 4 is 16 plus 10 is 26. All right. And the length of my hair is 26. So what does this show us? That we can take real world scenarios, create equations or models that represent them, and then use those to gather information about the real world. All right. So that's example 1. I don't think we need 2 examples here. So go ahead and just start on the you do and come back when you're done. Okay, hopefully you just finished the you do on your own. Let's go over it. The population of a small town is currently 500 people. Each year, the population increases by 8 people. Create an equation that represents its relationship between the population P and the years past Y. Again, hopefully you recognize this as a linear function because it's going up by the same amount each time. You use y equals mx plus b. And you were able to recognize that the town begins at 500 people. That's our constant. And that we have a increase of 8 people per year, right? Each year. So I can write that at 8y. Now all of this equals the population of the town. And so now I've created a model that represents this story. All right. The population is equal to 8 times the amount of years plus 500. And now I can use this model to figure things out. Someone says, hey, what will be the population of the town in 6 years? This might be something a mayor wants to calculate to build housing or whatever. And so, well, years is no longer an unknown. I can take this 6 and plug it into the y, right? Because y represents years. And so we can do P is equal to 8 times 6 plus 500. 8 times 6 is 48 plus 500 is the population in 6 years will be 548. Okay. All right. Hopefully you got that correct. We're going to add only a small twist to this one, so pay close attention. Alejandro has $400. He works a job earning $8 per hour. Create an equation that represents the relationship between his hours worked, H, and his total money, $sign. All right, so again, we're just going to create the model. He makes the same amount per hour, so this is a linear function. Wages are usually a linear function. You usually make the same amount every hour. So, all right, so I'm going to do y equals mx plus b. I know we begin at $400 because Alejandro already has $400. Every hour he works, he makes $8, and this is all equal to his total money. So we have an equation that represents how much money Alejandro has, right? He has 400 to start. He gets $8 per hour, right? So this equation is telling the same story as this actual story, just in number format. And in a way we can use, because now we have this question. He is saving up for a TV that costs $616. How many hours does he need to work before he'll have enough money to buy it? Well, this time I need to plug this 616 in, but I'm not going to plug it into H because this is not an amount of hours. This is an amount of money. There's no longer an unknown amount of money. I know exactly how much money he needs to have. He needs to have 616. So I'm going to plug this 616 into the money. So I can rewrite this equation as 616 equals 8h plus 400. Okay, and this equation, h, has one unknown, right? H is an unknown number to us. And that's the same as the question, right? The question says how many hours? Well, our equation is also really asking the question, how many hours? And we can just solve this two-step equation. This is why previously I was really stressing that you need to be able to solve equations. So we can just solve this two-step equation by subtracting 400 from each side. It's going to get a little messy. I'm going to run out of space. I'll finish over here. We get 216 equals 8h. Divide each side by 8. Oops. And we get these cancel. 216 divided by 8 is 27. You don't have to do that in your head. And so he would have to work 27 hours in order to afford that TV. After 27 hours, he could buy the TV. Okay. All right. Again, I want you to pause and try the you do. Okay, hopefully you're unpausing and you solve this pretty easily. I'm going to go pretty quick. Lamar has 4 subscribers on his YouTube channel. He gains $5 per month. Create an equation that represents the relationship between months past M and his total subscribers S. Again, this is a linear function because it has a constant rate of change. I'll use y equals mx plus b. And he gains 5. He already has 4 subscribers. That's where he starts. He's gaining 5 per month. And that equals his amount of subscribers. So here's the equation or the model. And in the question, it says, Lamar, how many months will it take him to get 39 subscribers? Because this 39 is dealing with the subscribers, I have to plug it into the S. So I get 39 equals 5m plus 4. You just need to solve this two-step equation. Subtract 4, subtract 4. 35 equals 5m. Divide each side by 5. And you get m is equal to 7. So it will take him 7 months. Okay. Hopefully you got that. All right. Last example. I want to go through this quickly. I don't want this video to be too long. Joshua is saving money each week. The equation below represents the relationship between how many weeks have passed W and his total money M. So it's a little different. We're given an equation, M equals 20W plus 200. Can we take this information and really say what it means? So what does the plus 200 mean? Well, Joshua's saving money. The plus 200 is the constant, right? That's where if I write y equals mx plus b over top, that's the beginning. And so he began with $200. That's what this means. Joshua already has. Joshua starts with 200. I wish there was a way to write these on here. All right, Joshua starts with $200. How much money does he make per week? Well, that's right here, right? That's the rate of change. It's a constant rate of change. What does this say right here? It says 20 times W. W represents weeks. 20 times the amount of weeks shows us how much he makes. So he makes $20 per week, right? Every linear function has a place where you start and a constant rate of change. So Joshua starts at $200. He makes $20 per week. That's the story that we're able to tell when given this equation. All right, last question. Go ahead and do this you do on your own. Don't forget to do it on your own. That's the most important part. That's where the thinking happens. Okay, go ahead and unpause. A river's depth is decreasing during a drought. The equation represents a relationship between the depth of river D and the weeks past W. So we have the equation D equals negative 5W plus 100. What does the plus 100 represent in this equation? Hopefully you got this. That's the starting depth of the river. All right, I'm not even going to write this actually, just listen. That's the starting depth of the river right here, right? That's where we begin. That's the constant. Well, what's happening? What does this negative 5W represent? Well, it's going down, right? It says it's decreasing. And we can also know this because that's a negative 5. So every week, the river is going down by 5 feet. All right. So, you could write that. Again, I'm not going to write it. It shows, the negative 5W shows us that it's decreasing by 5 feet per week. All right. So you have a beginning and a constant rate of change. All right. And so that's linear functions. Hopefully this video was helpful. If not, please see your teacher in coach class.